Okay, welcome back. I'm going to show you that how do we put in our rules so they are registered permanently, and any rules added by libvirtual do not affect that. But to do that, we must first analyze what libvirtual service do with the already existing rules. For that, I want to clarify the boot sequence and the sequence numbers of few key services so that you understand that what am I talking about. Let's change directory to etc init.d, and I would grab the word check config from all files, and I would grab the names I'm interested in, which is IPTables and libvirtual and XEN, and I would sort that on startup sequence number, which is key column number 4. So as you can see that when the system boots up, the various init services scripts, they start up or they execute in the following sequence. On sequence number 8, IPTable service start. Then various other services like these, they start up. Then on sequence number 97, libvirtual D service starts up. And on sequence 98, XEN D service starts up. And sequence 99, XEN domain startup, which basically starts up the virtual machines automatically on the system boot. And then on sequence 99, this is my custom made service, which does not come with any CentOS or Red Hat distribution by default. I created it myself, and I will show you what does this mean. At the moment, we just skip this. So these are the key services and their startup sequence numbers. Now to analyze, we are going to save the IPTables rules, and so that whatever rules we save are read by the IPTables service at its system boot up time, so we can see what rules get manipulated by the libvirtual D service. Alright, so IPTables save, and this time the output goes to /etc/sysconfig /IPTables, which is the data file, not IPTables config, IPTables only. This is the data file for the IPTables service. Press enter, edit the etc sysconfig IPTables file, and I'm going to remove all these rules which are there by default. I'm going to add my own rules, and my rules are like these. Add to input, this is pre-routing. Add to pre-routing minus j log, means send any traffic coming in on pre-routing to the log chain, and anything on the post routing log it, anything on the output chain of the NAT table log it. Then add to input chain j log, add to forward chain, add to log or send to log, add to output chain of the filter table and send to the log destination. I'll show you that this actually works. Add to input chain minus j log like this, and if you do IPTables minus list, your rule appears here at the bottom. The same is the case with the rest of the chains. Why I did that? I wanted to make sure that these rules, sysconfig IPTables, these rules are loaded by the IPTable service when it boots up at sequence number 8, and whatever rules are added by the LibVirtual service, we will see that what happens to our rules. So these log rules are just markers, so to speak. For this to actually take any effect, I would reboot the server, and before I do the reboot, I also want to make sure that my virtual machines, they actually start up when the system comes up. So what I would do is I would go to etc xen auto, and I would link a soft link from etc xen VM1 to this place and VM2 to this place as well. So there are two symbolic links here in etc xen auto. This means when the system or Xen service will start, Xen domains service will start, it will start up these virtual machines as well. So we'll save the botheration of starting these virtual machines. Alright, let's give it a quick reboot. It will take just 2 minutes. And while it boots up, I can show you anything in the KVM host which I want to do. It's almost the same. Let's try to reach VM1 inside KVM host. So let's see, we already added a DNAT rule mistakenly, if I remember, while we were trying to reach VM1 on Xen host. Yeah, this is a rule which is already there. Let's try to reach 192.168.1.202. We are getting a reject page. Why? Because the NAT rule works. It has seen one packet. Remember, we are on KVM host. NAT table has seen one packet matching to this description. However, our packet got rejected on the same rule which I explained in the previous session. This time I'm not going to remove this reject rule. I'm going to add my rule which I added in my previous session on the Xen host. Insert in the forward chain that any packet going to virtual bridge 0 accept. Simple rule. Now I try to reach 202 on port 80 and still waiting. What's happening now? Let's see. It has seen one packet and it's accepted, but why didn't it reach the VM? Is my VM running? Oh no, it stopped. Virtual shell start VM1. That is why I got the reject page, because it couldn't reach the target. Alright. My Xen host is already booted up, but before I move back to Xen host, I just want to show you this. Okay, try again. Let's ping my it's not started yet. Why? This is my KVM host and still booting up. Okay, it's booted up. Its name is test2, but we don't care. Its name is virtual machine 1 for us at the moment. It's pinging. Alright, so the web service should be up because I configured it to start at boot time. Try again. There you go. VM1 test2 inside KVM host. So this page is coming from the virtual machine inside the KVM host. We applied the same principle we applied on the Xen host and it is working. you look at the IP tables, you see the packets traversing this first rule which we inserted ourselves, and there are packets coming out of the virtual machine towards our direction. That is exactly why you see this rule having seen some traffic. Okay, so it's the same on XEN and KVM. Okay, right, so I just wanted to explain this to you. So to clear up, that's the same. Now I move back to my XEN host. Remember that the log rules we use, they will generate huge amount of log entries in your various log messages file. But I just introduce those rules to have some kind of markers, and this is exactly what I'm going to show you now. IPTables minus tnat minus list minus v. Okay, pay attention. This is pre-routing. This is, first of all, this is NAT table. This is pre-routing chain, and it has this only one rule, which is log rule, and it did not disappear. It stayed at its position. It's the pre-routing rule chain. So if this rule is already has stayed here, this was configured in the IPTables data file, and this rule exists, that means if any rule we configure in IPTables data file, it would appear here for the pre-routing chain. Check the post-routing chain. Post-routing chain shows that the masquerade rules which come from the LibVirt service are present or are added on top of our rule, log rule. This is our log rule, which has got pushed down, so to speak, in the post-routing chain. Now, since we don't want to do anything in the post-routing chain, as you must recall that during these 4 sessions, we have not done anything to the post-routing chain, and everything seems working fine. That means even if our log rule get pushed down, it doesn't matter. But it exists, at least it exists. It got pushed down, but it doesn't matter. And the output chain has only one rule, log rule, which we introduced, and there's no other rule here. This is the NAT table. I'm going to show you the filter table. If I just remove minus t nat and I do minus l minus v, see here, without minus v would be much better. Okay, here it is. See that our log rule exists in the input chain, but it has got pushed down, and libvirtual service has inserted these 4 rules on top of the chain, top of the input chain, and our rule is pushed down. Nevertheless, it did not get disappeared, and there is no reject all rules here, so to speak. So it's good thing. It's nothing to worry about. Okay, check the forward chain. Or before forward chain, because lengthy, I'm just going to show you the output chain. Output chain also has a log entry, log rule, and there is no other rule. That means that libvirtual has not done anything to this chain in the filter table, and our rule exists as rule number 1 in this chain. Let's come to most important, forward chain. Its policy is set to accept. That's clearly visible. What we see here is that our log rule exists at the bottom, just like the other chains. What's bad in it? The bad thing is that libvirtual has inserted its rule on top of our rules, and the rules which libvirtual introduced has these 2 rules which reject all traffic. Other than matching any traffic which gets matched in the first 4 or 5 rules, rest of the traffic gets rejected here. That means whatever we configure in our IPTables data file and it gets loaded up by the IPTables service, it will eventually be pushed down in the forward chain, and it will always be rejected. It will none of the none of the packets would ever reach this place because they will get rejected here at this place. None of the packets would reach here because they would always get rejected here. This means we cannot configure any rules which we want to add to the forward chain in the IPTables data file. That means if there are any rules we want to introduce to the forward chain and we want to insert them on the top, then we must have some mechanism that when libvirtualD service is done executing on sequence number 98, only then we execute some magical service and add our rules which we want to add to the forward chain. And basically, if you have seen here at KVM host most recently, the only rule which we want to add is to the forward chain. It is where is it? Come on. It must be here. Here. This is the only rule. This is the only rule which I want to add, or we want to add to the forward chain, but inserted on the top. So that means this should get executed after libvirtualD is done executing its service, whatever. So one method is to run this in the rc.local. That seems to be obvious place to add this rule without getting into complexities. In my paper I've explained that I've created a separate service, but you can make a note of it that there is no need to go through that hassle and simply add this rule to the rc.local, so it always get executed at the end. And configure any DNAT rules. Let's go back to our Xen host. Any DNAT rules in that IPTables file, because the DNAT rules will appear in the pre-routing chain, and that this chain doesn't get affected by the libvirtualD service. So that means, in simple words, we are going to configure our rules at two places. Okay, here is what I'm going. Here is how it works. Since I've recommended to use rc.local for the service, I can just remove. Okay, forget about it. I'll cover that later. Let's start from the basics. What are the DNAT rules we want to have? Let's go type history pipes through grep DNAT. Okay, so these are the two DNAT rules we want to use. Let's copy this and edit our sysconfig IPTables file, and this is the NAT table. I'm going to add these rules here. I'm going to remove the clutter, remove the log rules because they have done serving their purpose. Alright, IPTables -tnat is not required because that is what asterisk nat says above here. Okay, pre-routing incoming Ethernet port TCP destination to destination 41. Great. Next rule, -tnat, remove this part. Add to pre-routing Ethernet 0 destination port 8080 DNAT to destination 122.42. Perfectly alright. And then we do not do anything else in these chains because they will automatically get filled up by the libvirtualD service. We don't have any problem with that. We just want to add one forward rule to rc.local, etc/rc.local, and here I would add that rule, copying from this place here like this. This is pretty simple and you can probably get away by doing this. This works. However, if you want to be extra sophisticated, you can create a separate file, something like post LibVirt IPTables, and in that file I've defined that this file runs at sequence 99 when libvirtuald and ZenD both have done execution, or both are done doing their part, and both are done messing around with the IPTables rules. Then this service runs, and this service is very simple. It just inserts a rule on in the forward chain, and specifies that if the packets are coming from Ethernet 0 and going to virtual bridge 0, protocol is TCP and state is new, then accept that. This seems to be very complicated rule. We don't need this much complicated rule, although it will help you in the long run. But anyway, we can have a rule as simple as this one, that forward any traffic which is going to virtual bridge 0. That's all. No need to check if its state is new, no need to see if its protocol is TCP, because it can be UDP as well. But anyway, if you use just TCP, you are basically protecting against any unwanted traffic. If you're not running any service on UDP, then you don't want any UDP traffic to be forwarded in the first place. Alright, so a simple log message, the IPTables rule, insert in the forward chain to access VMs from outside, just a message, and it start and stop and all that, and it returns an return value. That's all. It's very simple, and it's provided in my paper as well. Okay, so now what? We are ready to give this machine another reboot, and I will show you that everything is ready when the system completes its rebooting. It takes time, but I have no other way to show it to you for your satisfaction. Okay, so it's rebooting, and this is our KVM host. It just sits there in my lab doing nothing. It's just another physical host, and just a different technology KVM host. We will discuss this in detail in some other video series, to be precise. At the moment, whatever I'm doing is perfectly understandable by just using the Zen host, and I've already shown you that it's the same on KVM as well. Alright, my Zen host is booting, and if you recall the web page here, we are done configuring the poor man setup. Okay, this is the poor man setup. We are accessing two virtual machines using a single IP but two different ports, right? So this is what you can do, and once the system boots up, I'll show you that the poor man setup is in effect and is working properly. Just wait. This is 202. We can close this. This is 201. Once this is done, we will move to the rich man setup. Time is also going to be up in 3 minutes. By that time it would be ready. Alright, I see ZenD service up, so that means I'm ready. If you would like to see the rules first, I can log on to the server first and show you everything. IPTables minus list minus tnat. Okay, you see that two rules which I added to the IPTables data file, they are here, and they did not get disappeared or moved up and down, nothing. I did not add anything to the post routing or output chain of the NAT table, so nothing wrong here. Okay, if I do just minus L, you see that this is my rule here, inserted here. This is my rule which came through rc.local. If you recall, etc rc.local, this is exactly what I defined. Since it doesn't have any IP addresses, you don't see it here. But if I can show you minus list forward, before going on, let me show you input chain has nothing wrong in it, only the 4 rules here added by libvirtual service. We did not add any rules to input chain so far, so nothing wrong here. Nothing's there in the output chain, clean. So the only thing we are concerned about is the forward chain, and here it goes. List forward like this, and IPTables save will be very clear to you. List forward again. Okay, look at the forward rules here. See, this rule is there after this 2 physdev rules. These 2 physdev rules. After that, this is our rule which we added in rc.local, and it got inserted at the proper place, which is right at the top. These 2 rules are further added at the top from XEN service because we configured it to do so. Otherwise, these 2 rules would have moved at the bottom. And if you are too curious, I can show you that where it is. XEN scripts with common. This is the file, XEN scripts with common, and here is the function frob IPTables. This is the place where I've changed -a to -i. By default it was -a. I changed it to -i so that it gets added on the top, but it has no effect, so just ignore it. So my rule is there on the top of IPTables forward rule, forward chain, and that's perfectly alright. Now let's go for the ACID test, and the ACID test is reach 201. I should be able to reach VM1. There you go, VM1. It's not coming from cache. I'll just refresh and you see it's coming from the actual virtual machine. If I do :8080, this one is coming from the second VM, and if I do a refresh on this one as well, you are sure that this is coming from the second virtual machine. Alright, so I can show you the stats. IPTables -tnat -list -counters verbose. You see I did refresh twice for simple 192.168.1.201, so that's why 2 packets here. I did one request sent to 201:8080, and it's going this way. This pre-routing chain, and you check the forward chain. Here is the forward chain. You see that this rule, which was added by us in rc.local, it has seen the traffic and has sent the traffic from left to the right side, that is towards virtual bridge 0. And the traffic which got out from the virtual machines is in this rule, right? Rest we are not concerned about anything else. Alright, so you have seen that how you can implement poor man setup. Remember, if you want to protect your XEN host, if I show you this, if you want to protect your XEN host from input, any attacks on the input, you can configure them in etc sysconfig IPTables file. You can add any rules in the input chain here, -a Ethernet 0 -protocol ICMP and blah blah blah, whatever conditions, and so you can protect yourself against some certain ICMP attacks and certain other sync and flood and different sync attacks and different DDoS attacks, whatsoever. Whatever you have in your mind for protection, you can put that in the input chain. You can put it here in this file and it will work. Alright, so that's it. The poor man's setup is complete. I would cover the rich man's setup in the next video. So just stay with me for one more session, and it should hopefully be over.